In this video, we'll see the benefits brought by simulation during the design phase. So let's fly through into the assembly, into the model, and I would like to focus on this part, on this duct. This duct is in charge to bring cool air, to refresh the head in charge of burning the wire for the 3D printing operation. So from SpaceCam, I switched to Discovery, same file, and it's of course fully compatible. And you can appreciate the interface of Discovery, completely redesigned with a lot of enhancements, but you are not lost at all. Okay, you will find the same menu, the same shortcut, the same way to work. So I would like to extract the fluid volume there, but you see the part is not well designed. So what I propose you is another technique where I have to recreate the fluid volume from scratch. So I do some, I would say, some adjustments. So I would like to remove the rounds, and I'm gonna have to copy paste the edges to recreate the different boundaries, the inlet and the outlet of the fluid. So as usual, copy paste. To extract the edges, okay, and based on these edges, I'm gonna have to fill them to recreate the surface to have the boundaries of the model. You see that? What's interesting, you can still work on the wireframe model. You don't have to reach any special tools. You can just drag and extend and trim and reconnect and repair the wireframe model. Okay. So that's pretty interesting. So there, I'm creating, as I mentioned, the different boundaries to have the direction of the geometry I have to create, because I will create a blend in between these parts. Okay, and then you can see on the sides the history with all of the bodies, and I can quickly access, of course, with the eggs and the halo. I have all the commands I use most of the time located there. So some cleanup, because the fluid, the original fluid geometry was not super perfect. And what I'm doing right now is I activate the history tracking. Okay, so this is super helpful in this case, because I'm recording the different features, the different steps I'm doing right now. So you see, I recreate the blend, and now I'm recreating a straight connection from this face to the other geometry. So this is how the original fluid volume has been created. Okay, and I have exactly the same geometry right now. So what I have to do now is to define the boundary condition, the fluid condition. So I define a volume flow rate based on my fan characteristics here, and on the other side I have two outlets. So the pressure is equal to 0 because okay, it's just an outlet in the air without any special stuff. So everything is set. I can control on the side. I just have to change the fluid. So I have access to a fluid library, a material library in general. You can customize it, and of course, in this case, it's pretty basic. It is air. I run the simulation, okay, and I would like to focus on two specific stuff. I would like to control exactly the value at some location. So in this case, I have to select the two outlets because I would like to control what happened exactly at the two outlets. In the ideal case, it will be something like 50%, 50% for both of them, okay, but okay, I can go closer to this value, but I'm not expecting to go there. So the first thing is, you can see there is a pretty fast solve and a very nice rendering when I can appreciate and understand what happens. And what you see there is the velocity, the speed. So in blue you see the low speed. So with this view it's much better because I have the view of the hair spread among the different outlets. And you see on the top one, I created a kind of blade effect. The airflow is going on the bottom of the outlet. It's definitely not well spread. So what is definitely not well designed, okay, because I have a big outlet and I use only a small portion of the outlet to extract the air. And it's because of that. You see that with the flow path, I clearly saw the vortices, I see the recirculation of the air, and with the low speed here. And with this view, I have another way to see that. It's also pretty interesting because I see how the fluid is split. Okay, so you see the difference between the blue color and the red one. Okay, the boundary layer is completely broken for sure because there is a sharp edge based on the geometry. Remember, I created a smooth with a blend and a straight one crossing in the middle. So that's why I have this, and this is why I have this effect. So I saved all the different results. I created some scenes, okay? And if you look at the values of my monitors, you see that there is a ratio of 3. So one is 3 times bigger than the other one, so definitely not the good one, okay? So let's see how we can improve that. And thanks for the history tracking, because I can come back in the history and I can read it what I did. So I'm gonna have to suppress the straight, I will say pipe connection, and I'm gonna have to replace that by a blend. Okay, so just to have a much better, a smoother geometry to help the fluid to follow the good direction. Okay, so I can read it, all the different features, I can change the option, I can rebuild them one by one to be sure that my model is correctly rebuilt, or I can rebuild everything in one time. This is what I'm going to do right now. Okay, just I don't have to recreate them one by one. So what is interesting there is everything is preserved, the boundary condition, the scenes, the monitor rule, everything. I just need to press solve again and to see the impact of my geometry change on the simulation. Okay, so as you can see there, yeah, it's pretty fast. Okay, and if I click there, you see with the bubbles representation, I directly improve that. Okay, it's maybe not yet perfect, but you can quickly appreciate, and especially with this view, that I decrease this, I would say, blade effect, where the air was extracted only on the small portion of the outlet. So, and there I can clearly see with the vorticities and with the flow path, and there, when I look at how the fluid is split, okay, you see, of course, I preserve the quantity, I preserve the curvature of the path, so that's much better. Of course, in this case, I still have a split, but it's because of the geometry. I could continue to change the geometry and to optimize it, but I would say for a first test, it's enough. Okay, I improved the design, and you can see that in just a matter of minutes, I did the job. And if I look exactly at what's happened with the monitors, so what is interesting with the monitors, I can track the different values for the different design changes. Okay, so you see that you have the values for the first design. So I'm sorry, I missed the top and the bottom one. And of course, the sum of both will still the same. So if one is improved, is increased, the other one decrease. And I did the job. You see that if I look at the values, I improved by almost 30% the flow volume extraction of the outlet of the bottom level, the top one. So job done. So now what I have to do is to, from the fluid volume I created, I have to recreate the solid around to have the perfect shape and the original shape I had. So I could do that in SpaceClam for sure, but let me show you that Discovery is not just a tool for the simulation. I can also do all the geometry step I did in SpaceClam and even better. So what I'm doing right now is just copy paste the reference faces I had in the previous geometry, okay, and I can reuse that to recreate the geometry, okay, and make the cut, and I would say something pretty common for a SpaceClam user. I would like there to pay attention at what I'm doing right now. I'm creating some runs, okay, but in this new version of Discovery, we also improved a lot the geometry kernel, and you can really appreciate how complex the runs can be, and I can have a run crossing another one and crossing again another one. It's much better and much powerful than what we did in the past. Okay, so let's continue and to finalize the design. Okay, and just to be sure, I can probably add some runs just to show you again what I told you. Okay, so when all of that is done, okay, just a few seconds, okay, a few steps, now I can switch back to SpaceClam to see the result in SpaceClam. So remember, I preserved my history tracking, so all the features are preserved in SpaceClam. So I can, in SpaceClam, read it, redo what I want, and the geometry there. Okay, that's just beautiful. And of course, you can continue to add an extra feature, okay, and this can be edited, okay, as usual, okay. So you see the compatibility between Discovery file and SpaceClam file is complete, Okay, you have no doubt about that. You can use both. You can use both at the same time. So when the design is done, I can switch to my main assembly. Okay, and now the only thing I have to do is to replace my old design by the new one and to see that it will be in place exactly at the same location. So you see how fast and easy it is to introduce a simulation during your design process. It helps to understand how your product behaves. It helps you to make much better product. And even for a non-simulation expert, it adds you a lot of added value.